The old classic projectile problem. And this problem is so important for anyone who experiences gravity, which is you. If you have a projectile, if you throw something or you shoot something, it is going to follow a certain path. That thing is called a parabola, and it can be modeled by a quadratic equation. So what we have here for this problem is we have a building, and we're somewhere maybe on a ledge or on a window below the top of the building, and we're taking an object and we're dropping it down to the ground. Now they give us some information here, and some of it really you just don't need for this problem. They're telling us that the top of the building is 1,472. And we're dropping it from 28 feet below. So if you subtract 1,472 minus 28, you're going to get 1,444. Okay, have you seen that number? Yeah, it's right here. It's already in the equation. So really, we don't need to know any of this. It's good to read the problem. We drew a diagram, but we don't need to know any of this to solve this equation. Now, what we do need to know is we need to know that they're asking us for how many seconds pass before the object reaches the ground. And there is something we need to know over here. What is your height on the ground? And if you're down on the ground, your height is 0. So basically, we're going to take that 0 and we are going to plug it into the equation right there for height. Once we do that, that'll be our equation, and then we can use our mathematics to solve it. So let's go ahead and let's do that. Start with the equation that's given right here. H equals negative 16t squared plus 144. H equals negative 16t squared plus 1,444. And we're going to plug in a 0 for h because the height is 0. So right here, plug in a 0. Now we have our mathematical equation. 0 equals negative 16t squared plus 1,444. Okay. We read it. We drew a diagram. We made an equation. Now let's use our mathematics to solve. This is a quadratic equation. And we can factor this. We can solve this one by factoring. I put the steps for factoring a quadratic equation down here to remind you. Step 1, it must equal 0. Does this one equal 0? Sure does. And to help you remember that, I put a smiley face in the 0. Step 2, factor completely. Okay, let's go ahead and let's factor it. Greatest common factor. Do I have a greatest common factor here with negative 16t squared and 1,444? Well, I can't take a t out. Can I take a number out? Yeah, I could take out a 2. I know they're both even. I know 2 goes into them. But we're going to try a bigger number. We're going to try maybe 4 or 8 or 16. Okay, so I pick up my calculator and I divide both of them by 4. And I find out that, yes, 4 goes into both of these. Okay, then I'm going to try 8. I know 8 goes into 16, right? I take 1,444 divided by 8, and it doesn't go evenly. I end up getting a decimal. So my greatest common factor is 4. And what I'm going to factor out, since the leading term is negative, I'm going to factor out a negative 4. Let's do it. Negative 4, and I'm dividing that out, and I will get 4t squared when I divide it out of the first term, minus, okay, I am dividing a negative from a positive, so it's minus, and 1,444 divided by 4, let's see, what's that? 1,444 divided by 4 equals 361. 361. All right, I have taken out a GCF, right? I'm one step closer to being factored completely. Can I factor this thing right here? Well, boy, it sure looks like the difference of two squares. I know 4t squared is a perfect square, right? 2t times 2t. I pick up my calculator, I try 361, and I'm going to find out that 361 is a perfect square. It's 19 times 19. So here's my 0 equals -4. And if this is the difference of two squares, I write my two binomials, and they are going to be conjugates. My first two terms are 2t and 2t. 2t times 2t gives me that 4t squared. My last two terms are going to be 19 and 19. They multiply to give me 361. These are conjugates, so one of them has a plus and one of them has a minus. Am I factored completely? Yes, I am factored completely. Step 3, set every factor equal to 0. So, here's a factor, here's a factor, and here's a factor. Let's set all three of them equal to 0. So, I have -4 equals 0. I have 2t plus 19 equals 0. And I have 2t minus 19 equals 0. And now let's solve every one. All right, this first one, -4 equals 0. Is that a true statement? Does -4 equal 0? No. Okay, I will get no answer here. I don't even have a variable to solve for. So let's look at the second one. 2t plus 19 equals 0. All right, I need to get grumpy old t all by herself. I'm going to need to get rid of that plus 19. So I'm going to subtract 19 on both sides of the equal sign. These two turn into a 0. So I have 2t equals 0 minus 19 is -19. One more step to get grumpy old t by herself. I'm going to divide out 2 on the left-hand side, and I'm going to divide the right side by the same thing. These turn into a 1, so t equals -19 over 2. All right, that's one of my possible answers. Now, let's work this one right here. It's a linear equation, right? T to the first is linear. So to solve this, I need to get grumpy old t by herself. I need to get rid of the minus 19 first. So I will say plus 19 on the left side of the equal sign and plus 19 on the right side of the equal sign. -19 plus 19 turns into a 0. So I have 2t equals 19. Right, 0 plus 19 is 19. And one more step to get the grumpy old t by herself. I need to divide out this 2. So on the left-hand side, 2 over 2 is 1. 1t equals, and on the right-hand side, it is 19 over 2. Okay, now, I'm not super excited about these numbers. Yeah, they're fractions. They're improper fractions. But they might be the right answer. Let's go ahead and check them. And let's make sure it makes sense. Okay, we solved them. Now, come right back up here. We used our math to solve. Now let's check our answers. Let me ask you, this one right here. Is it possible that time could be a negative time? Does anybody know how to go back in time? Not yet. So that can't be the answer. So this is my only possible answer, 19 over 2. Now, when I go back and I look at the problem, it tells me to type in an integer or a decimal. So you can use your calculator. Let's turn this into a decimal, 19 divided by 2, and you're going to find out that t equals 9.5 seconds. Okay, and I'm okay with that. I think if you dropped an object off of a tall building, it might take 9.5 seconds to go down. I have no problem with that. If you really want to check it, you could take it and plug it in to the original, right? But I'm going to say that there's no reason for me not to believe this. And that's it. We're done.